All right, so I'm going to go over how radicals work and how we deal with radicals, the basics in algebra. All right, so this covers 1.6 through 1.10, so it's going to be a little lengthy, but not a big deal. Okay, so what is a radical? We'll start off with that. Well, a radical is just another way to write a number raised to a fractional exponent. All right, so we started off with x to, like, say the 1/2 is like the easiest explanation. This is the base and this is the exponent. Right? Well, in a radical, we can change this to the radical. This is the radical. The base turns into what we call the radicand. Okay, the top number becomes the exponent of the radicand, and the bottom number becomes the index of the radical. Okay, typically if you see the square root of something, this is just the square root of x here. Right? Normally you don't write 1 if it's x raised to the 1, because anything raised to the first is a self. And typically if we see a square root of something, the square is just like it's blank. Right? So this is just the square root of x. Right? But if we had something like a little bit more complicated, like 3 square root x raised to the 3/2, right? Well, let's make it a little more challenging. X raised to the 2/3. The 2/3, right? This would change into x, right? So x becomes my radicand, right? And then 2 is my exponent inside, and then this is the cubed root of x squared, right? So that how is these get converted into this. This becomes your radicand. This becomes the exponent of your radicand, and this becomes the index of your radical. So that is how that becomes that. This becomes your radicand. And so that's how all of that works there. Okay, so that's that. Okay, so so there's more. So this, yeah, that's pretty much all I wanted to cover there. So there's more to it than. Well, I guess we can show an example real quick. So, like, say we had like 8, right? And we wanted to raise it to or 8 raised to the 1/2, right? 8 raised to the 1/2 is just as simple as 8 square root of 8, right? And we'll get to this in a second. Or say we had 8 to the 1 cubed. Well, 8 to the 1 cubed is the cube root of 8. Right, so the cube root of 8, and we know if you type it into a calculator, we'll get back to this in a second. We could go 8 to the 1/3 is 2, or you can do 8 to the second 3 is also 2. All right, 2 different ways to see it. You probably couldn't see that really well because of the lighting on here. Sorry about that. But anyway, I'm going to show you how to do it on paper anyway. All right, so there's that. So real quick recap. Right, this is the radical. This is the radicand. This is the exponent of the radicand. And this is the index. Okay, this can also be written as index parentheses to the exponent. It can also be written like that. Okay, so there's that one. All right, now say, before we get into dissecting radicals and reducing them and making them, simplifying them, we want to review factoring. All right, so factoring is, say we have like 104. And we want to find all the basic things that I have to multiply, all the prime numbers that I have to multiply together to get 104. So I'm like, oh man, my brain is not firing on all 4 cylinders. Let me just do, well, 2. And this is an even number, so I know 2 is one of them. The other number, well, 52. So 52 times 2 is 104. Well, that's a prime number. I'll move that down. And then the two prime numbers, or two numbers multiplied together to get 52. Well, we got 52, think for a second, and well, 26. 26 and 2. Okay? Erase this real quick so it lines up nice. And 2. All right, so that's another prime number. So I'm just going to move that one down, that one down, that one down. And what makes up 26? Well, 13 and 2. So prime number, prime number, prime number, prime number. Let's multiply them all together real quick. 13. Let's see. So do I have that light on? There we go. 13 times 2 times 2 times 2, and I have 104. Great. Now, let's say that this was all under a radical. Cubed root, or the square root. This is the square root of 104. Well, I need to find a square, something squared to pull out of it, right? One, I can find a perfect square. So perfect squares, let's say, I'll make a chart over here. All right, so if I have 1, 2, 3, 4, 5, 6, 7, 8, 9, or 10, and each one of these is squared. Right, this is 1, 4, 9, 16, 25, 36, 49, 64, 81, and 10. So if I find any of these under my perfect square, I can pull it out. These are called perfect roots. I can pull this perfect root out as its square. Okay? So if I found a 4, I could pull out as a 2, and then the 4 would go away. Okay, but I don't really have that in here. Okay, so say I had, like, here's an example. Here's an example of that. Say I had 8, the square root of 8 in here. We had that earlier. Okay, well, 8 breaks down into 4 times 2. Well, 4 is a perfect square of 2. So this comes out as a 2, and the 4 goes away, leaving me with 2 square root of 2, and that is reduced. Okay, so this, I don't have that situation. However, I could make a 4 by multiplying 2 and 2 together, but that would be an extra step. Another rule of thumb you can think of is, remember, this is a 2. The index of that is a 2. It's invisible, but it's a 2 nonetheless. Right? I can also say, well, if I have 2 of the same number, if I multiply it together, it becomes a perfect root of that number. Right? So I don't really have to go back and do all the extra work. I can be like, okay, I have a 2, and I have a 2 that makes a perfect square of 4. Right? So I don't have to do that. I can be like, okay, well, I have 2 of the same number. That would pull that number out. Oh, sorry, that's wrong. That's a 52. That was one level up too high. Sorry about that. Undo that line. It was on 52, 52. Okay, it's on this line. I have a 2, and I have a 2, right? And that is going to make 4. So I'm just going to pull that 2 out, right? And what is left inside the radical is 2 square root of 26. Right? And that is what the square root of 104 is. And I can double check. Right? I can do 104 square root. It's that number. It's that number. I'll do it again. 104 square root. It's that number. Okay? And then I have 26 square root. 26 square root times 2. It's the same number. Right? So these are the same. Okay? So that's how you reduce a radical into its same term. Okay? So say for instance I wanted to add radicals together. Okay, so just like adding like terms together, or combining like terms, like a 2x and a 5x, say this is a negative 2x and a 5x. If I wanted to combine these two terms, I can, because these are like terms. Like terms. They both have an x. This one's negative, this one's positive. I combine them together, it makes a 3x. Okay? In order for radical terms to be like terms, they must, 1, have the same radicand. Radicand. So the number in the side must be the same. Okay? Radicand is this number. That number must be the same. Okay? And then 2, they have the same.
Good morning, can I have your attention please? Mr. Little, please go to the media center.
They must have the same index. They must have the same index. So this number must be the same. Okay? So say I wanted to add 2 square root of 3 together, and with I wanted to combine 2 square root of 3 with square root of negative square root of 3. I can do that. I can do that, right? The coefficient of negative square root of 3 is an invisible 1. Okay, you can't see it, it's an invisible 1, right? But it's still there, it's an invisible 1, because 1 times square root of 3 is square root of 3. So 2 minus 2 square root of 3 minus square root of 3 is square root of 3, right? Because it has the same radicand and the same index of invisible 2, invisible 2. Okay. However, if I had like 3 square root of 5 plus 2 cubed root of 5, I cannot combine those because they have different indexes. If I had 2 square root of 7 minus 3 square root of 2, cannot combine those because they have different indexes. Okay, so that's how you do that. They have to have like terms in order for these to be like terms with radicals. These requirements must be met. Okay? All right, so lastly, we're going to talk about multiplying and subtracting radicals. Okay, and this is pretty easy. First off, if we ever have a fraction that has, say it's 5 or 3 divided by square root of 2. In algebra, this is like having an unsimplified fraction. Okay, we don't do it. We don't put radicals in the denominator. This is bad. Bad. No radicals in denominator. All right, so in your simplification step, undo it. And we undo it by multiplying this by 1. Multiply by 1 in the form of the radical. Okay, so that means, hey, in the form of the radical, it's 1 in the form of the radical is just square root of 2 over square root of 2. Square root of 2 over square root of 2 equals 1. Square root of 2 over square root of 2 equals 1. It doesn't change the value of this, but what it does do is the top becomes 3 times the square root of 2, and if I multiply 2 square roots together, or 2 cube roots together, or 2 fifth roots together, I get square root of 2 times square root of 2 equals, well, square root of 2 times 2 squared, or the square root of 4, because you multiply the things inside the radical together, or you can look at it in terms of this. Right? What do you do with, sorry, let's do 2. Let's do it like this. 2, law of exponents say 2 is 1/2 plus 1/2, and that says it's 2 to the first, in which case this equals 2. All right, so either way, if you have a squared inside and the index is at squared, these nullify each other, making it 2, or the square root of 4 is 2. Right? So that's 3 ways to prove to you that this equals 2. Right? This equals 2. If this was like 4, right, now you can say, all right, well, this is just 2 square root of 2. Right? So that is how that whole thing works. If you have something, so when you're multiplying radicals together, I'll clarify that again. Say you have square root of 15 times the square root of 23, right? Oh, it's 24. 24. There's a couple ways you can do this one. 24, 20, well, 24, sure. First, you can do 15 times 24 and come up with 360, right? Or you can break this down, square root of 360, and then break it down. Or you can be like, okay, well, this is the square root. This is the square root of 3 times 15. Oops, sorry, 3 times 5. And then this is the square root of 3 times 8, and that is the square root of 3 times 2 times 4. And bring that down, that's just 3 times 5. And then I can multiply these two things together and be like, that's 3 times 5 times 3 times 2 times 4. And if I multiply all that together, it's 360. And I can be like, oh, I have 2 3s. I can bring those 2 3s out together, and that makes a 3. And then I have 5 times 2 times 4, and 5 times 2 times 4, that's 10. That's 40, a square root of 40. I wonder if I can pull a 3 square root of 4. Well, I can pull a 10 out of that and make 4 times 10. And then I can be like, oh, okay, well, this is a perfect root. Pull a 2 out of that. Okay, and then this will become a 6 square root of 10, and that just breaks down to 2 and 5, which are not perfect roots, so that's my final answer there. Okay, or you could have just dissected this the same way and you would have ended up with the same answer. Okay, so different ways there. Okay, so say for instance another, and then dividing is even better, and this kind of brings the whole thing home, why we're doing this whole thing to begin with. All right, so why do I want to reduce things like this? So say for instance I had that on the bottom. I had that square root of 15 times 24 on the bottom, and I ended up doing all that on the bottom with, and I finished up with 6 square root of 10 on the denominator, and then on the numerator I started off with 6, or with 12 square root of 10, right? So my original thing was like 12. Yeah, no, we'll say it was like a 6 square root of, oh, it was gonna be 3 times the square root of 20. Does that work? No, that doesn't work. Square root of 40. Square root of 40. Because that would bring out 2, and then with the 10. Divided by, that's 2. That would make that 6. Plus 6 square root of 10. So that would give me my 10 square root of 20. Or 10 square root of, that would give me 12 square root of 10, divided by a square root of 360, right on the bottom, right? Then that would give me this. So when it was all said and done, I could do this, right? I could divide those 2 out. Those 2 square root of 10s would go away, and that would leave me with 12 over 6, which equals 2, right? So something fairly complicated looking ends up being pretty simple. Okay, so I hope all this, it may have seemed rushed, but this applied with some practice ends up being pretty easy. And remember, if there's like a negative sign in front of one of these, the whole thing's negative, and it just turns this negative. No big deal, okay? But if you have a negative sign in front of here, on the other hand, and this is even, not possible, okay? If you have a negative sign in front of here, right, and this is odd, then all of your factors are negative. Okay, that's a helpful hint too. All right, that's it. Have a great day.